All right, let's pull back the curtain on one of the most fundamental yet kind of secret concepts in all of computing. It's the silent, unsung hero that makes everything from your mouse click to multitasking actually work. We're talking about computer interrupts.
I mean, think about it for a second. Right now, you might be typing, listening to music, getting notifications. Your computer is juggling a ton of stuff all at once. So how does its brain, the CPU, know what to pay attention to and exactly when? Well, the answer is this surprisingly elegant signaling system. And to really get why this system is so brilliant, you first got to understand the core problem it's trying to solve. And honestly, it all comes down to a massive difference in speed. See, your CPU is an absolute beast. It can perform billions of operations every single second. But you might type, a few characters a second? So if that lightning-fast CPU had to just sit there and wait for your next keystroke, man, what an incredible waste of power. That's like forcing a Formula One car to drive in a rush-hour traffic jam. Just painful.
So what was the first crack at solving his problem? Well, it was a method called polling. And look, it's the most obvious, straightforward solution you could think of. But as we're about to see, it's also wildly inefficient.
Okay, with polling, the CPU is basically like a super anxious host at a party. It's constantly running around to every single guest, every device connected to it, and asking, hey, you need anything? No? Okay, how about now? You need anything now? It just keeps checking again and again and again.
Here's the best way to think about it. It's a great analogy. Imagine for a second your phone didn't have a ringer at all. To see if someone was calling, you'd have to physically pick it up and check the screen every few seconds. That right there, that's polling. You can just feel how insanely inefficient and distracting that would be, right? And yeah, that is the crucial point. All of that constant checking eats up valuable CPU cycles. The processor is busy doing busy work, just asking if there's anything to do, instead of, doing actual productive computation. It's just a huge, massive waste of resources.
But, thankfully, there is a much, much smarter way to do this. And this, right here, is the real game changer. It's called interrupts, and it completely flips the script on how this whole communication thing works. So an interrupt is, well, it's exactly what it sounds like. Instead of the CPU constantly pestering devices, asking if they need help, the device itself sends a signal, an interrupt, to the CPU only when it needs attention. It's a notification, not a constant interrogation. It's the don't call us, we'll call you model of computing. And this comparison just lays it all out, crystal clear. On one side, you've got polling, the watcher. The CPU is wasting its time constantly asking, you need me yet? Then on the other side, you have interrupts, the notifier. The CPU just gets on with its work until a device sends a signal. Let's go back to that phone analogy one more time because it's perfect. Polling is you checking your silent phone every 5 seconds. An interrupt, that's your phone actually ringing. You only give it attention when it actually needs it. So much better. Okay, so we've established that interrupts are way more efficient. But what actually happens, step by step, when that signal finally arrives, let's walk through the life cycle of an interrupt. It's really like a beautifully choreographed dance. First, a device, say your keyboard, sends the signal. The processor immediately slams on the brakes, pauses what it's doing, and this is the crucial part, it saves its place. We'll come back to that in a sec. Then, the operating system jumps in, finds the right little mini program for the job, which is called an interrupt handler. That handler does its thing, like registering your keystroke, and once it's all done, the processor just reloads its safe spot and picks up right where it left off as if nothing ever happened. And that whole act of saving its place, that's got a name. It's called context switching. And this is the real magic that lets the CPU handle an interruption and then just jump right back to its previous task without missing a beat. It's literally like putting a bookmark in your book before you answer the phone. That way, you know exactly where to start reading again. Simple, but brilliant. This right here just illustrates the urgency perfectly. Take a look at this instruction pipeline. So at cycle 4, bam, an interrupt is detected. And look what happens next. Everything else in the pipeline is immediately flushed, just wiped clean. All that work that was partially started, gone. It's thrown out to make way for the interrupt service routine, or ISR. It really shows you that when an interrupt comes in, it's a stop everything you're doing right now kind of event. Okay, so this brings up a pretty logical question, right? If a keystroke can interrupt whatever you were doing,
what happens if another interrupt arrives while that one is being handled? Like, can an interrupt interrupt another interrupt? Oh, the first and simplest way to handle this is to just ignore everything else. The processor basically puts on blinders. It temporarily disables any new interrupts, finishes handling the one it's working on completely, and only then does it turn interrupts back on and check to see if any other signals piled up while it was busy. It's orderly, for sure, but it's not always the fastest way to do things. But then there's the much more sophisticated approach, priority handling. And the best way to think about this is like an emergency room. Let's say a signal comes in for potential power failure. That's a critical patient, right? That gets seen immediately, even if the doctor is currently handling a less urgent case, like a simple mouse click. A high-priority interrupt can literally pause a low-priority one, making sure the most critical stuff always gets handled first. It's triage for your computer.
So let's zoom back out for a second. We've gone pretty deep into the mechanics here, but why does any of this really matter to you? Well, it's because this seemingly simple signaling system is what makes our entire modern computing experience even possible. Think about it. Every single time you click your mouse or type on your keyboard and see an instant response, yep, that's an interrupt. The fact that your computer can download a huge file in the background while you're browsing the web, that's all managed by interrupts. Those critical real-time systems in your car or in an airplane, they absolutely depend on priority interrupts to keep you safe. Heck, even your laptop going to sleep and then waking up the second you open the lid, that's an interrupt at work. They are literally everywhere. When you get right down to it, interrupts are basically the nervous system of your computer. They're these silent, invisible, but absolutely essential signals that allow a super powerful but kind of solitary CPU to talk to the rest of the world. And that's what creates the responsive, multitasking experience that, honestly, we all totally take for granted every single day. So the next time your computer feels snappy and instantly responsive, you'll know the silent hero that's working behind the scenes. And hey, if this deep dive helped you understand a little more of the magic behind your machine, do us a favor and don't forget to like, share, and subscribe to Tech Talk 101. Thanks for hanging out with us.